Hi students, today we're going to talk about arcs and chords on a circle. So just to review what a chord is, it is a segment with two endpoints on the circle. So we have a circle, and then we have an endpoint here on the circle and an endpoint here on the circle, and we connect them, a segment in between, that's a chord. Sorry. So let's look at a new theorem. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So example 1, use the figure to answer the questions below. Which two chords are congruent? So you should remember these little tick marks mean that things are congruent. So 1 and 1, 2, 3 lines. So that means that AB is congruent to CD. So segment, oops, sorry, AB is congruent to CD. And these are segments, so they get the little bar over them. Which two arcs are congruent? So if these segments are congruent, then that means that the arcs above them are congruent. Okay, so arc AB, so we're going to do the same thing, AB, with the points, but instead of a line over it, or a segment, we're going to put an arc. So this should be more curved. But, It's congruent to CD. Arc CD. What are the measures of their arcs? So the total measure of arcs degrees added up is going to be 360 because that's just kind of the magic number of circles. We're going to subtract the values we already know, so 20 and 220. Okay, so this is going to be 120. Now it wants each of the arcs, and we have two of them. So that means we need to divide this by 2, and the measure of the arcs is going to be 60 degrees each. Okay, if PS equals 12, so this is PS, and TR equals 15, then find QR. So we want to know QR. So QR arc length is 70 degrees. SP's arc length, we don't know, it's broken into two sections. So we need to add them up. So 50 plus 20 equals 70. Now remember before, if our arc lengths are the same degrees, then our chords are the same units. So if SP is 70 degrees and 12 units, our Q is going to be 70 degrees and 12 units. Find HI. Okay, so we need to find this arc length. So we're going to do 360 minus 91 minus 78, and I'm just taking these arc lengths that it gives us, minus 113. And if you subtract all of those, 360 minus 91 minus 78, you will get 78 degrees. So this is 78. Oh, well notice, is there another arc length that's 78 degrees? Yes, there is. So the chords are going to be the same length. So this is 9 units. This will also be 9 units. Let's look at our new theorem. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So AD and BC are perpendicular, which means they cross a right angle. AE equals 12, so this segment is 12, and the radius is 13. Okay, well AD is 13, so 13 minus 12 is 1. Find the following. ED. Oh, we already said that was 1. AC. So if we drew a line from A to C, wouldn't that be a radius? From the center to a point on the circle? Yes, it is. The radius is 13. AB. Same thing, that's a radius. EB. EB, we have to do a little bit of math. Okay, so it said that these are perpendicular, so we know it's a right angle. So let's draw it. This is A, E, B. We know this length is 12. We know this length is 13, and we want to know EB. Okay. So if you use Pythagorean theorem, you could find this. So you would say 13 squared equals 12 squared plus x squared. And you would do the math and you would get 5. So this is 5. Okay. EC, well, it says that it bisects it, so EB and EC are actually congruent. So it is also 5. And so BC is them combined, so it'd be 10. Yay. If the measure of arc, see how their curves look nice? That's how mine should have looked. CFB, so this whole giant curve, that is 220 degrees. Okay, so they want to know arc of CB. Understandable. That's this arc. So remember, you're going to need to subtract. So we're going to have 360 minus 220, which is 140. Okay. Okay, find a measure CAB. So starting at C to A to B, it wants to know this angle. So you're probably like, well, how do we even find that? Okay, we found arc CB was 140. So this is what's called a central angle, and it has the same degree as the arc does. So if the arc connected by those segments is 140, then this angle is also going to be 140. Ah, so ugly, sorry. Okay. And this is called central angle, and that's how we know it. BAD, so right here, it's half of it. Remember, this bisects, we know it bisects, so the angle is also going to be the same. So half of 140 is 70. And then CD is the other half, which is just going to be the other 70. Okay, let me know if you guys have any questions. Bye!